differentiation in calculus is just about gradient, right? So we've been restricting our discussion of different kinds of gradient functions to polynomials and things with powers, right? But that's going to kind of break open. We've got trig functions to look at, logs, exponentials, and so on and so forth, okay? So therefore, before we get onto those, and the number of things you learn how to differentiate just kind of balloons out, I want to make sure we're good with these, okay? What we've been developing over the last week or so, okay? So let's review. So far, you kind of learned 4 rules, if you like, for how to differentiate functions. And by the way, differentiation rules is actually the name of the topic that this comes under, even though I consider this and limits in calculus is sort of really 2 parts of a whole. Okay, so that's why I haven't made a big deal about it. This is a new topic because it just continues through. Okay? So I want to review. I think we said 4 rules. Okay, can we remember what they are and put them all in one place? If we differentiate something with a power on it, okay, so you can call this the power rule or the polynomial rule because that's what polynomials are. Okay. Something say x to the n. Can we remember it? Can we get it into our heads? What do we do first? Okay, good. Take the power down. The power becomes the coefficient, right? And then you reduce the power by 1. Okay. Now, by the way, you've got to know these really, really well. That's why I keep on going over and over and over these again. Because towards the end of the year, we're going to learn the reverse of this process, which is called integration. And if you don't know these well, you're going to be sort of really in trouble for integration. And you'll also even get the 2 confused. Okay. So let's sort of drill it into our heads. Then we learned 3 other rules that relate to different kinds of things, different ways that these are combined. Okay, so we learned the chain rule. Okay, now I'm going to try and put these in as succinct a form as I can. So if we're differentiating one function, let's call it f, right? Which is really a function of another function. So let's call that g. Okay, so if you like, you would call g your inside function because it's inside all of those brackets. And you call f your outside function, right? What do we do? This is chain rule, right? So if you remember, the acronym we learned for that was right. Okay, the most important of the letters being the 2 middle ones, right? The inside function, you differentiate that first. So you'll end up with g dash, okay? And then you differentiate the outside, which is f dash. Okay, so like I said, we've mentioned this before, right? This whole dash notation thing, we generally try to avoid it, except when we're learning these rules because they're always going to look the same each time. Okay, so that was chain rule. Then what was the next one? Product rule. Thank you.
Yeah, I don't know what after that.
Okay, so it's when we're differentiating something which is one function multiplied by another, and we call them u and v. So if this is what I've got, by the way, here on the left-hand side, I'm putting my u of x and v of x just to remind you that u and v aren't just variables, they're actually functions of x. Okay? So, do you remember what was the thing here? Hey, I didn't make it up, okay? Yeah, it's a VOOV, right? I seriously, like, I made this up, but this one is in textbooks everywhere, okay? You can go check it and see it's legit. Yeah, it's for real. Okay, sometimes they put it backwards. They have uvu, but I think that's confusing because the next rule is quotient rule. And I believe the very last thing we did was we derived this result. Really, quotient rule is just a special version of product rule. Okay, so for instance, when you've got u on x divided by v of x, right? U of x. What do we get? Well, the numerator looks very much the same. The difference is there's a negative in the middle. Okay, so you've still got a VOOV of sorts on the top, and then you're dividing by v squared. Okay, good. All right, so that's what you've learned so far. Okay, now learning these, by the way, is not enough. Because so far I've given you exercises for each one, but because it's an exercise specifically devoted to, for instance, learning the product rule, you sort of automatically, your mind is on autopilot, because it's like all of these questions have to do with product rule, so you're automatically going there. In reality, and in like exams and that kind of thing, they'll give you a question and it doesn't tell you nice and neatly, use this method or use that method, right? So you have to discern, okay? Now you might think, well, isn't it obvious when you've got a product, you should use the product rule? When you've got a quotient, you should use the quotient rule. Well, not so fast. So let me give you 2 examples. Okay. Suppose I asked you to differentiate this. Okay. So this is a nice, easy example. On the face of it, it looks like A quotient. So you would use the quotient rule, right? And you can. You'll get the right result. But a way better approach to this is to say, well, look, on the denominator here, I can divide both of these terms by that denominator, right? So this is really the same as asking x squared on x is just x, and 1 on x is 1 on x, okay? And that is tons easier to differentiate, right? Because that's just 1, and this, the power comes out the front, and then you reduce the power by 1, so 1 minus 1 over x squared. And you'll get that, you know. You can see, you know, v over v squared, so there's your v, there's the v squared appearing, right? It'll get the same result, but our quotient rule will be much, much longer, okay? And in the same way, if I said, well, okay, differentiate something like this. I don't know. Okay, you look at that, that's a 2, by the way. Again, it's a quotient, right? But a much better way to approach it would be, in takers, this is chain rule. Well, I mean, it's both of them, but it's better to consider as 2x minus 1 to the minus 2. Okay? So how would you do, derivative of, right? So what would you do here? What's chain rule? You go for the inside, okay? So it'll be 3 times 2, there's the inside. And then you bring the power down, and then you reduce the power by 1. Okay? So what's that? 3 by 4 is minus 12 on 2x minus 1 cubed. Okay? Now, I'm not going to go all the way, but just to demonstrate how inane it would be, what would happen if we didn't rewrite it and then do it as chain rule? If we thought of this as a u and a v, okay, how's it going to start? It's going to be 2x minus 1 squared, that's v, then u dash, which is 0, minus u, v dash, so you're doing chain rule again, 2 to the 2x minus 1, all over 2x minus 1 to the 4, right? Now actually, this turns out to be not that bad because of this 0, but number 1, it takes longer just to write this down. Like in the time it took to write this down, I could have solved it already. And number 2, because there are so many extra bits, it's a far more error-prone method, okay? So it's a bit like sort of pouring like boiling water with your Anker hand, right? I mean, like it'll work, but you're sort of asking yourself to get burnt, right? So in general, when it comes to looking at these methods and picking the right one, almost always it means avoid the quotient rule like the plague. That's the main thing to get, okay? But the sheet I'm going to give you is sort of a mixed sheet, so it lets you look at the questions and then pick which method or which combination of methods you should use, okay? Does anyone have any questions on any of that?